if you like. Okay. So let me repeat that again. When you're working with word problems and you see the words difference, minus, or decrease by, you know that that means subtraction, but you're going to subtract in the order that you see the numbers in the problem. If you see the words subtracted from, less than, or fewer than in a problem, you're still going to subtract, but you have to switch the order around that you see it in. So, for example, let's say the problem said, what is 10 less than 25? You wouldn't write 10 minus 25. You would flip it around and you would write 25 minus 10. That's what I mean by switching the order around. This last phrase here, how much more, is another one that is confusing to some people because they see the word more in there and they assume that that means addition. Let me go back. More than means addition, but you have to have it as a total phrase, that phrase together. How much more means subtraction. Again, as an entire phrase. It's not just the word more, it's the whole entire phrase as a whole that means one or the other. For example, if I have $10 and Megan has 20, how much more does she have? She has $10 more than me, and you would just subtract it to get that. Moving on to multiplication keywords and phrases. Again, this isn't in a complete list, but these are the most common ones that you're going to come across. Of is one that is missed a lot. Of means multiply when it is between two numbers. So I'll show you some examples of that. And then division. Here's some division words. Quotient is what we talked about last week. And the word per means division, and that's the one that's missed a lot by people. Equality is pretty much straightforward for all of these. Any of these phrases just means equal to. Okay, so now let's try to put it in play here. We've got a couple of examples that we're going to go through. I'm going to try to translate it all out for you, and hopefully by me modeling that, it will help you read these for yourself. So 4 sections of algebra were offered in the spring semester with enrollments of 33, 34, 26, and 23 students. What was the average number of students per section taking algebra? Okay, so they're giving us the number of students in each section, and they want to know the average number. So one of the first things I'm going to do after I read it, go back, see what they gave me, figure out what the question is asking, and if this is what they want, and I don't know what that is, I might need to look that up. So to find the average of something, if you forgot, here's what you do. It's the sum of the values over the number of values. Sum means add, so you add up all of your numbers and then divide by however many you had. So in a case like this, I'm going to add up 33, 34, 26, and 23, get my total, then divide by the number of values I had. There was 1, 2, 3, 4 of them. So I divided by 4 and plug that into my calculator. So on average, there were 29 students per section. Oops. Now, before I talk about the next one, the last step is, does this seem reasonable? So after I checked my computation, which 29 students is correct if I divided 116 by 4. But just because I divided correctly doesn't mean my answer is right. Does this make sense as an average for the number of students? So the word average is the middle point. Could 29 be in the middle of these 4 values? Does that make sense? Is it reasonable? What do you guys think?
Makes sense.
Okay, good. I mean, I hope so. Because again, average is the middle. Some students add up, give me an answer of 116 and move on, and they forget to divide. Or they do multiplication right here, I'm going to get an even higher number, which none of that would make sense if you're trying to find the middle of this. 116 is definitely not in the middle of any of this. Okay, so stuff to think about, keep in mind as we go. All right, here's another one. It says a corporate exec picks up a rental car that has an odometer reading of 16,560 miles on it. When he returns it, the odometer reads 16,782. How many miles did he drive the car? And then if the rental company charges $2 per mile, how much would the corporate exec be charged? All right. So if they need to know how many miles he drove, what they want to know is basically what is the difference between the ending point and the starting point. So I'm going to subtract those two amounts, and that'll tell me how far he drove. So again, I just plugged this into my calculator. We've already been through how to do this by hand, so at this point, we're going to be using the calculator. You can certainly work it out and then check it if you like, if you'd rather do that. So I subtracted, got 222. So he drove 222 miles. Whoops. And then for the second part here, if they charge $2 per mile, that's $2 for each mile, for one. But he drove it for 222 miles. So to find the total cost, that means we're going to multiply. $2 for one times 222 miles that he drove is $444 total. Any questions about any of this so far?
No.
Okay. All right. Here's another one. A basketball coach orders shirts for his team that is sponsoring a local charity event. Shirts size large cost $22, while extra large cost $28. If 8 large and 6 extra large are ordered, find the total cost. So again, this is one, you can do this actually in a couple different ways, but what they want to know is the total cost of the large and the extra large. But since we have two different sizes that cost two different prices, we're going to break it down and then add it up at the end. So first I figured out how much the large shirts would cost us. We're buying 8 of them at $22 a piece. That's $176. And then 6 extra large are $28 each. So multiply that, we got $168. And then for the total cost, that means I added up those two pieces and got a total cost of $344. And that's it for that one. There's one more. We'll go on to the next section. So John wishes to pay off his car loan of $4,560 in 24 months. How much will his monthly payment be, assuming he pays the same amount every month? Okay, so we've got a total, and we are trying to make it, we're trying to divide it up into 24 equal payments. So I just said it, that means division. So I divided the cost by the number of months, which gives me $190 per month that he'll have to make in order to get this paid off. All right, so is everybody ready to keep going?
Yeah.
Okay. So next up, this is section 1.9. We're going to talk about exponents and order of operations. So starting with the exponents, because this is used in the second part. An exponent, if you don't remember what this is, it's used to represent repeated multiplication. So instead of writing out 3 times 3 times 3 times 3 times 3 over and over and over again, you can shortcut the notation and make it an exponent. The 3 is called the base, That's the big number. And that big number tells you what number is being multiplied together. And then the exponent indicates how many times it's being multiplied. So there's 1, 2, 3, 4, 5 of them. That's what this notation is trying to represent. If you're not sure what to do, the best bet is to take this form and rewrite it out the long way and expand it out. Usually when people do that, they can go left to right and just work it out. When something is written this way, it's called exponential form. So be on the lookout for that on your homework. They'll just ask you, for part of it at least, to just take a problem that's written out like this. This is called factored form, and rewrite it in exponential form. You don't actually have to give the actual answer though, if that's all they want. Excuse me. Okay, but if they ask you to evaluate, that's a different way. It's a different vocabulary word there. They are asking you to give the answer. So what I did was I took all of these in exponential form and expanded them first and then answered them. So hopefully it's more clear. So 6 to the second power, which is also read as 6 squared, means 6 times 6. It does not mean 6 times 2, which is what some people confuse this as. It's 2 6s. 6 times 6 is 36. And so there's my final answer. For B, it's 5 to the third power, which is also read as 5 cubed. That means 5 times 5 times 5, 3 of them. Not 5 times 3, 3 5s multiplied together. So 5 times 5 is 25. 25 times 5 is 125. So here's my final answer for that one. And then the last one is 2 to the fourth power. There's no other names for once you're about 3. So it's just 2 to the fourth power, which means you need 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And that's it. So again, make sure if you're struggling with these, make sure you write them out first. Usually that helps. There's a little trick with powers of 10, only with powers of 10 now. This does not work for anything else. When you're looking at the exponent of a power of 10, that indicates how many zeros you will need on the end. So if you have 10 to the first, that's just 10 because you need 1 0. 10 to the second is 100 because you need 2 zeros. 10 to the third is 1,000 because you need to have 1, 2, 3 zeros, and so on. It exists all the way for forever, up to infinity for that. But again, it only works for 10s. Okay. Any questions so far?
No.
Okay. So then let's move on. So the order of operations. This is, you'll probably remember this as please excuse my dear Aunt Sally. That's what this is right here. So step 1 for the P means you're going to work out anything you see inside parentheses first. If there's nothing to do inside and you do have parentheses in your expression, those parentheses might be there for something else, so you hold them off to the side for now. But if you can do anything inside, that's the key word here. That's where you start. Next, you're going to go to the E. E stands for exponents. Exponents and square roots actually are done at the same time. We're not really going to go into the square roots right now. Look for any exponents that you have. Do those next. Next is step 3. Step 3 confuses people because they think that these are 2 different steps. They are not. Step 3 is multiplication and division together in the order that they appear from left to right. So if you see a division sign first in a problem and then a multiplication comes later on, you need to divide first. Then you multiply. This is all one step. These are not separate. And it's the same for the last one. With addition and subtraction, you do that left to right in the order that you see them in the problem. when I jot this down as a reminder, this is how I write. Please excuse my dear Aunt Sally. I write them next to each other to try to help you guys remember not to do multiplication and division separately. Do it all at the same time, just go left to right throughout the problem. So here's a quick example, and then from here I'm going to work the rest of them out on the whiteboard so you can see me go step by step. Here's a quick example of what could go wrong if you don't do it in the right order. This is only a two-step problem. First of all, let's talk about the parentheses that are there. If you look inside these parentheses, there's just a 2. You can't do anything inside them. There's nothing you can do to just a single number. That means the parentheses are there for something else. And in this case, they are here for the multiplication, the 5 times the 2. So if that's how I start, which is what you're supposed to do, 5 times 2 is 10, and then 18 minus 10 is 8. This is the right answer if you follow the order of operations. Over here, if you look what happens if you don't follow the right order, then you just go left to right throughout the whole thing and subtract first, which some people want to do. 18 minus 5 would have been 13. And then 13 times the 2 is 26. And it's not even close. So the order will make a difference through every single piece. You've got to do them in the right order if you want to get all the way down to the right answer. Okay, so here is where I'm going to start with the whiteboard. Bear with me for 1 second. Okay, so according to the order of operations, I don't have any parentheses to deal with, so I can skip that. I don't have any exponents to deal with. I can skip that. Multiplication and division comes next, and I do see division, so that's where I'm going to begin. Right in the middle of the problem, which bothers people sometimes, but this is how it needs to be done. Follow the operations first before you start going left to right. The other thing that I would suggest is as you're going through these problems, especially if you struggle at all, go step by step and bring everything else down that you're not using to keep yourself organized. So if I'm only going to do this right now, 10 divided by 2 is 5. I'm going to isolate that little part. I'm going to work it out, and then I'm going to bring everything else down that I'm not using. And then I'm going to take another look at it and see what I have to do next. I don't see any more multiplication or division. So I'm going to move on now and look for addition and subtraction. Since this is one step, not 2 separate steps, same thing, I'm going to go left to right, working it all out as I go. 15 minus 5 is 10. Bring down the plus 3, and then 10 plus 3 is 13. And that one's done. Oh, that's a little bit better. Okay, let's look at another one. And I'm going to pause 1 quick second. Okay, sorry about that. All right, this By the way, I'm just following along. If you've got the notes from Blackboard, I'm following along with the problems that I have posted there. You can always go back and look at this later if you want to. So now you do have parentheses. So we're going to take a look inside of them. Inside there, you can do something. You can subtract. So we're going to start there. 7 minus 2 is 5. And then I'm going to bring everything else down that I didn't use yet. So the 300 division sign. I'm going to keep these parentheses around the 5 for now because it had an exponent attached to it. If that wasn't the case, I could have dropped the parentheses. And then the minus 2 squared. And parentheses stuff is now done. Now I'm looking for exponents, and I do see these two here. I can do them both right now. So 5 to the second power means 5 times 5, which is 25. And over here, I want to do this too before I move on. 2 squared is 2 times 2, which is 4. I don't see any more exponents, so I'm going to bring everything else down. And then my exponent step is done. Moving on to multiplication and division. I only have division, so I'm going to do that next. 300 divided by 25 is 12. Bring out everything else down. Multiplication and division is done. And then last, when you're looking at the last step, all you should see is adding and subtracting. And I do, so I know I'm good. My final answer then is 8. All right, any questions at all yet?
No.
Okay, good. All right, let's keep going. Okay, here's C from the notes. Now I see 2 sets of parentheses that I'm going to start with. I can do these both in one step. So 5 minus 3 is 2. 8 minus 6 is also 2. Bring everything else down. Okay, inside my parentheses, I got them each down to one number, so that's done. Now for my exponents, I've got 2 of them. 2 to the third means 2 times 2 times 2, which 2 times 2 is 4, 4 times 2 is 8. Be careful right here. It's not 2 times 3. It is not 6. You need to write it out if necessary. 2 times 2 is 4 right here. And my exponent is done, so I'm going to drop down. The only thing I haven't used yet, I have no multiplication or division. My answer is 12. Okay, now the last one is long, so I might need to continue up at the top there. Okay, here's what this last one looks like over here on the page. Let's looks kind of crazy. So let's go through it slowly. You are going to see something like this on the homework. So if you can do this, you should be able to do all of them. Something to start with that we haven't talked about yet is what in the world are these squared off looking things? Those are called brackets, and they're just a different way of writing parentheses. They use different types to try to show you clearly which ones are supposed to go together. But if you, for example, if you had something that was written out in color, they could have also easily just done this, just to show a little bit clearer which ones are supposed to go together. These two go together, these two go together, and then the red ones are supposed to go together. But usually things are typed out in black, so to get around that, they just use different looking ones. Okay, bottom line is, if it looks like a parentheses and it's close, it probably is parentheses. When you have more than one set like this, you have to work from the inside out. So I'm going to do these two things inside first. They are the innermost sets of parentheses in the problem. Then I can take another look and see what I can do with those brackets. So 3 plus 1 is 4. 7 minus 2 is 5. That takes care of the inside parentheses, and I'm going to bring everything else down, including the stuff on the outside, just so I don't lose track of it. And just like with multiplication and division, if you have more than one thing to do, you just have to keep going before you go on to the next. So I'm not done with my parentheses step until I add this up now. So 4 plus 5 is 9. Now the parentheses are done. I don't see any exponents, so I can skip that. Now I'm going to look for multiplication and division. I see multiplication here, and I see multiplication here. So I can do those together. 9 times 4 is 36. 5 times 7 is 35. Bring everything else down. Multiplication and division are done. Last but not least, subtract it for your final answer. And everything else is done. Okay, that's the last problem for the order of operations questions. Do you have any questions for me at all?
No.
Okay, good. All right, so let's talk about the last part. I'm going to go back to the PowerPoint actually for this. Okay, so we're on the last part. If you're following along with me on your tracking calendar, we skipped around for this part, what we're about to start. We just finished up 1.9. Factors of whole numbers in your book is section 3.2. I don't know why they put it in a separate section, honestly, but it really should be with whole numbers. So that's why we're doing it. So factors, let's go back and talk about what factors are. Factors are numbers that are being multiplied in a question. We talked about this last week. The answer, in this case would be the 6, is called the product. What you're going to be asked to do now in this section is not to take two factors, multiply them together, and find a product. You're going to be working it backwards. You're going to be given a product and asked to come up with all of its factors. That's called factorization. So the issue with this is when the number is, well, when the number is small, it's not too bad to find all of them. But when the numbers are large, trying to find every single thing that multiplies together to give you a certain answer can be a little bit difficult. So there's a strategy that I'm going to show you that you should use. It helps you systematically find all of them, and it will also let you know when you're all done. Okay, as an example here, besides 2 times 3, those are 2 factors of 6. 1 times 6 would also multiply to 6, so those are also 2 more factors. All right, so let's talk about a little bit larger of a number like 12. If they want you to find all of the factors or the factorization of 12, here's my strategy. Start with 1 and the number. Those will always be in every list because 1 times anything is the number itself. So start with that so you don't forget them. And then systematically start dividing since you're working backwards. Starting with 2, then go to 3, then go to 4, then go to 5. Don't skip around. Go in order. Once you find one that works, list its pair with it. So here's what I mean by that. The next one would be 2. So 12 divided by 2 does work. The other pair is 6. Because 12 divided by 2 is 6. When I multiply this back, 2 times 6 is 12. So I'm going to go in order that way, dividing by something, and if it works, listing the pair. So next would be 3. 12 divided by 3 does work. 12 divided by 3 is 4. So I'm going to list those 2 together. Then the next one would be 4. 12 divided by 4 is 3. We just wrote those 2 right here. So as soon as I see a repeat like that, like 4 times 3 would have been next, that's when you know you can stop. So if you do it in order, listing pairs, not only will you not miss any, hopefully, but you'll also see once you get a repeat here, you'll see when you can stop. That means you don't have to check 5, you don't have to check 6 because 6 is already there. You don't have to check 7 because 7 won't work, 8 won't work, and so on. Once you see the repeat, you're done. Let's try another one. So all factors of 36, we're going to start with 1 and the number. Then I'm going to go to 2. So 36 divided by 2 does work because 36 divided by 2 is 18. Then I'm going to go to 3. 36 divided by 3 also works. 36 divided by 3 is 12. Next, I'm going to go to 4. 36 divided by 4 does work. 36 divided by 4 is 9. Then I'm going to go to 5. 36 divided by 5 does not work, so I'm not going to list it. Then I'm going to go to 6. 36 divided by 6 works, and the answer is 6. And right here, I see a repeat. It could be an entire line like the last problem was, or it could be 2 repeated factors right here within the same line. Doesn't matter, it's still a repeat, so we're done. We don't have to check 7, we don't have to check 8. The next one that would have worked would have been 9, which we already got, so we're done. Here's all of the factors then. How are we doing so far? Any questions before I do the next one?
No.
Great. So here's another one. All the factors of 50, starting with 1 and 50. Then I'm going to go to 2. 2 works. Its pair is 25. 2 times 25 is 50. Then I'm going to go to 3. 3 doesn't work. Then I'm going to go to 4. Then I'm going to go to 5. 5 is the next one that works because 5 times 10 is 50. Then I'm going to check 6. 6 does not work. 7 does not work. 8 does not work. 9 does not work. The next one would be 10. So since I already have that one, I know I'm done. And here's all my factors. All right, one more. Factors of 72, or 1 and 72. Then we're going to check 2. Since this is even, it'll definitely be a 2. 2 times 36 is 72. Then I'm going to check 3. 3 times 24 is 72. Then I'm going to check 4. 4 times 18 is 72. 5 does not work. And it's on to 6. 6 times 12 is 72. Then 7. 7 does not work. 8. 8 times 9 is 72. The next one would have been 9, which I just wrote, so I know that I'm done. So here's all my factors. Okay. The reason we're talking about this is once we get on to the fractions chapter, this will come back up, and this is a very useful strategy for when you're reducing fractions and simplifying. So just as a preview for why we're talking about it at all, that's why we're doing it. But if you see here, we're all done. Do you guys have any questions about anything we talked about today?
No.
Okay. Let me pull this back up real quick then, before we end. All right. So I saw some of you did turn this into me. This was the homework from last week that was due today. If you did not turn that in yet, try to get that to me as soon as possible. Just work it out on paper, scan it, or take a picture and email it to me as an attachment. For today, this was what we were doing today. 1, 8, 1, 9, and then 3, 2 of the factors. Here's the homework assignment that goes with that. It's a lot shorter, and it is due by next Wednesday. So that's it. That's all you guys have to worry about for now. Just as a preview for what's coming next week, take a look. We're going to wrap up the rest of this chapter and review for your first test. So your first test is coming in 2 weeks, just so you're aware.